Good morning. My name is Gardinalli. I work for SGI in Brazil. I'm here with Fabio, our systems engineer. I think everyone listened to me well. I was also told to make my presentation in English. I was not prepared for that, so sorry if I have to say something in Portuguese or take some time to say it in English. So I'm a sales account manager at SGI. Fabio is our systems engineer, and we are here in Brazil for a very long time. I'm from the old Silicon Graphics times, and we'll talk to you a little bit about our platforms, how we integrate solutions like what our friend from NVIDIA showed into our products, right? So I'll skip this because you are tired of this. Everyone knows big data explosion. Everyone knows it's growing a lot. The only number I will show at you is back in 2009, the data of the world were 130 exabytes. So they're expecting that 2020 is going to be 44,000 exabytes. So that's how fast it's growing, right? And how you address that is our problem. That's why we are all here. So that brings problems to everyone, every IT community, from universities to corporates. Everyone has to deal with stretching of IT resources. Everyone has to deal with out space of IT space, data center problems, power problems, schooling problems. So everyone is facing that, right? So you had to change the way you do R&D, you have to change the way you do HPC. We need to face, I think the biggest problem is power. Power is key for us to achieve the exaflop or whatever other flop we need to achieve in the future. So a little bit of history, SGI, 30 plus years in the market. We have been through different process. Silicon Graphics became SGI, we have 600 patents in 50 countries, and the focus today is high-performance computing. From the ones who remember Silicon Graphics in the past, the focus was visualization, right? So we're trying to bring some of that back with remote visualization, use of NVIDIA cards, and some software that we have called vServer. We're trying to get back to the visualization world, but the focus is HPC. Here in Brazil, we have been doing a lot of HPC stuff with universities like USP, UFRJ, in the northeast of Brazil, UFBA, UFRM. Recently, we have sold a big system at Senai in Bahia, and I'll show what the system is. But the focus is really HPC. From really the small one, if you have a single server with lots of GPUs inside, or if you have a big cluster, 100 nodes, 200 nodes, 800 nodes. That's our focus. So more history. The big data term was presented by SGI back in 1996. So we had a show, we were in, I think in a supercomputing event, and we had this big machine there. They had 128 cores or 128 CPUs at the time, shared memory system, and people were already talking about big data. So it's not new for us. 2003, NASA ANSYS had deployed the system called Columbia. It was number 2 in top 500. It used the Intel Itanium CPUs, was a shared memory system. 2007, we deployed a very large installation of storage, hierarchical data management storage at NBA. It's live today. We have around 16 petabytes of storage. 2 years ago, Total is the number one system, or it's not the number one system in top 500, but it's the number one production system in top 500 that is not research driven or research usage. And last year, IVAC, it's what we call the square kilometer array. We deployed a 100 petabyte installation for a very large database. They have 1 square kilometer of antennas looking at the sky. All the data there is collecting is throwing to this big storage solution. So we have been doing this for a long time. Our commitment to innovation, we spend 8% of R&D in 8% of our revenue in R&D, and the focus are performance, power in cooling, density, and user experience. I think this is the most important portion, right? User experience. We are not here delivering boxes. We are not here delivering iron. The idea is that we deliver a solution, end-to-end solution. With ourselves, with our own products, with third-party products, and sometimes with partners like Versatos that are here. So we try to give the best user experience to the end user. On the software side, on the hardware side, on the support side. That's our goal. And the foundation is everything, right? So we have different choices of networking. We have our own networking, what we call Numalink. We use commodity networking, InfiniBand, fiber channel, Ethernet. We have our own storage. We have third-party storage. We do Lustre, we do ANSYS, we do 6FS, NAS, SAM. And on the compute side, we have different options too. We have cloud and shared cluster and shared memory solutions with the management tools and services, and we focus on different applications. One thing that we've done in the last 10 years that changed a lot is SGI or Silicon Graphics had its own CPU, operating system, and graphics cards, so that changed. We adopt the market solution. We adopt the x86 as a solution. We killed the Unix that we had, the IRIX, and brought all the information or all the developments that we had in IRIX into Linux. And our solution today is based on x86, GPUs, and Linux. So that's where we are. Factory integrated, that's important. Our systems come integrated from the factory. We bring everything installed in a rack. You're not going to receive boxes or cables in one place, box in the other, the rack in the other. It's all integrated in the factory. So it's easier for the user to start using the system. The areas of focus, technical computing, big data, storage, and the applications on the top of the slide. Telco, media, financial services, manufacturing, research. Research is everything. Weather, chemistry, physics, whatever, computational chemistry, bioinformatics. We focus in all those areas, right? And a little bit of the products. So we have different products to address different needs and different budgets, right? So we have, our base product is the rackable cluster. So if you're building a small cluster up to 2 racks, we can address with this solution. If you want to go larger, like the system we just sold, we have what we call ICE product. ICE is integrated cluster environment, and it brings commodity x86 solution, GPUs, ZM5, into a very dense and very performant platform. So we have tuned everything we could to transform the system into very performant, very efficient product or system. And when a cluster is not enough for you to do your work, we have our UV platform. It's our shared memory system. So with UV, you see here a picture of 5 racks, but in 4 racks you can put 2,000 cores and 64 terabytes of memory. It also holds up to 16 GPUs or up to 32 Xeon Phi cards. Right? So our job, our daily job is to help the users, the researchers, look at the applications and put them in the right solutions. So just an example, in CFD or CAD space, right? We have all these applications, right? So in case of ANSYS Fluent, ANSYS CFX, we know it scales well. It's not very dependent on the bandwidth, so it would fit well in a rackable cluster. Same thing for explicit computational structural mechanics or electromagnetics, right? So it fits well in a cluster. We understand that we have a bunch of engineers that have tested those applications and has tested in different platforms. If you look at different set of tools, different set of platforms, like transient CFD or implicit CSM, those applications or doesn't scale well or need a lot of I/O. So those types of applications or need more memory goes into a UV platform. So that's what we do. We get their application, we will test them both, and help you decide which platform to go. Business case at NASA AIMS, the SGIICE. So the ICE system at NASA today has 2.88 petaflop speed, so it's 166 racks, more than 200,000 cores, and the beauty of the system is it has been installed since 2006. We have been expanding the system since 2006. It started with, I forgot the name of the CPU from Intel, but it started with DDR InfiniBand. Then it grew and we added QDR InfiniBand. And the latest implementation, we added FDR InfiniBand. It's all in a single fabric. It's a single cluster. You can use any piece of it. There are 4 generations of CPUs. Today we have Westmere, Sandy Bridge, and Ivy Bridge. We had Harper-Tone device, all in a single system. And it's true, I have a testimonial here because Adriano was there 2 weeks ago and he saw it working. And the way we do it is because we do some things different in the interconnect. We use InfiniBand, but we do things different in the interconnect. We have a hypercube topology that allow us to add different types of network and also do live integration. Every time they upgrade the system, we bring another rack. We tell the network, stop listening for a while. We plug the new racks and tell it to listen again. So the hypercube, it's here, 11D today hypercube, and that's part of our secret sauce, right? So we support different topologies in this environment. Which is the right one? Well, it depends on the application. We tested all of them. It's also a matter of cost. So depending on how much you want to invest in your network, all to all, you connect all the nodes together. In a factory, when you start growing a factory, you have problems to add stuff and you have a lot of cost on the switches. In a hypercube, each vertex is a group of nodes. So when you add to that, you add more links, but you don't need to add extra switches. The switches that comes with the system are enough for you to connect the whole system. It's a little bit more complicated than that. We don't have time to go through it today, but I can do it if anyone is interested. I can talk more about it later, right? So hardware, topology, and power and cooling. So power and cooling is being important. So in a traditional rack, Today, we can add 72 nodes in a single rack, 42U rack. What we have done different recently, we have doubled the density per rack. In a single rack, we put now 144 nodes, and we encapsulated 4 racks into what we call a cell. So this cell is 2.5 meters by 2 meters, so it's 5 square meter size, and it holds 576 nodes. And I could put it here, if I had water to cool it down, I could put it here and you wouldn't need air from outside, right? So it's very dense and helps a lot with reducing the power consumption from the system and from the infrastructure, from the data center. And you can add as many as you want. So I'll show you a case of this one. Our customer Total, they have made a video that shows a little bit of the system. We don't have sound, but sound's not important in this case. So the system is installed in France, and they call it Pangea. They have 12 cubes in a single system. And as I said, those are the cables in the middle are the InfiniBand cables connecting everything. We use the Mellanox chip in our solution, Intel CPUs. This system doesn't have GPUs or Xeon Phis, but we could hold it. In a single blade, we have 4 CPUs in a rack, 72 blades. Yeah, and then it goes. So it's a lot. It's about 10,000 cores per cube. We have 12. 2.3 petaflops. That's the peak performance of the system. So what we do different is the cooling system. And we can cool the system with water used at 25 degrees Celsius. We could do it at 32 Celsius. We could save you a lot of power in cooling the system, right? We have what we call warm water cooling dissipation system, cold sink, and it also uses air internally, so you don't waste air, you don't disturb the data center, because the air is encapsulated inside. Right? They also have a very big file system, very performant, 7 petabytes, 300 gigabytes per second. So that's part of what my next slide. I'm going to stop here and you've seen it. Part of the solution is the I/O, is the storage, right? You cannot have a big system like that and forget the storage. You gotta have a balanced system. So we do have storage solutions, RAID systems, object store, and archive solutions. The archive is very interesting because it allows you to have your fast storage as small as possible, and you use the archive system to put your data that you're not using in a safe environment. But the thing is, we still allow you access to the data. So we don't take the access to the data out of control of the user, because users like their data, they want to hold it, right? So we keep the access to the user. That's key for an archive solution to work well. And we have many examples here of big customers doing archive with us. Total is here, that's their old installation, not the new one. They have more now. NBA is here, 15 petabytes, and NASA is the larger one. The largest one today is this one at IBAC. So it's 100 petabytes of online storage, or nearline storage that all the users have access to. Last but not least, we have services to implement all the solutions. We can, again, do it ourselves with our professional services team or with partners like Versatos. We have local support. We have a local parts and engineers to support all the customers in Brazil. And we also have education services. We have training that can be done locally or can be done in our factory in the USA. And that's it. Any questions?
Any questions?
Thank you.